Hi everyone, I am Madam Rosmaya. In this video, we are going to solve an essay question on alternating current. An LRC series circuit is constructed using a 160 ohm resistor, a 25.0 microfarad and a 12 millihenry inductor, all connected across an AC source with voltage V equals to 48.0 sine omega t at resonance angular frequency omega. Find A. the resonant angular frequency, B. the impedance of the circuit, C. the maximum current in the circuit, D. the phase angle between current and voltage, E. at the instant that the current is equal to 1/2 its greatest positive value, find the voltage across the resistor and the capacitor. Question A. The resonant angular frequency, omega. At resonant frequency, XL equals to XC, reactance of inductance equals to reactance of capacitance. XL is equals to omega L and XC equals to 1 per omega C. Cross multiply omega times omega, we get omega squared and equals to 1 per LC. Omega equals to square root of 1 per LC. Okay, we substitute the L and C into the equation. Then we get omega resonant angular frequency 1826 radian per second. Okay, another method we can use is from formula of resonant frequency. F naught equals to 1 per 2 pi square root of LC. So to get omega, we times 2 pi both sides. So 2 pi F naught is equals to the angular frequency omega, and cancel out 2 pi to this 2 pi, then we get 1 per square root of LC. Substitute LC value into the equation, then we get angular frequency equals to 1826 radians per second. So both methods give the same answer. Next, question B, the impedance of the circuit, Z. Okay, the solution is using the formula of impedance equals to square root of R squared plus, in bracket, XL minus XC squared. At resonance angular frequency or resonant frequency, XL equals to XC. So therefore, XL minus XC equals to 0. So this means the equation become square root of R squared plus 0 and equals to R. So R value is 160 ohm. So therefore, the impedance of the circuit is 160 ohm. The maximum current in the circuit, I naught or I peak. The solution is from V equals to IZ, so I equals to V per Z. So if you use I peak, V also must use V peak. So V peak can be calculated or can be found from the voltage given, which is 48.0 sine omega t. So compare with the general equation V equals to V naught sine omega t. So V peak is 48.0 volt. So substitute into the equation here. And then Z from question B is 160 ohm. So 48.0 divided by 160 ohm is 0.3 ampere. So this is the maximum current or I peak for the LCR circuit. Okay, next, question D, the phase angle between current and voltage. We use symbol psi. Okay, the solution, in the series circuit we have resistor R. So for R, I and V are in phase. So therefore, the phase angle between I and voltage, or current and voltage, is equals to 0. Okay, and lastly, question E. At the instant that the current is equal to 1/2 its greatest positive value, find the voltage across the resistor and the capacitor. So the solution is, for resistor, we do for resistor first. So from the equation V equals to IR, okay, I is 1/2 its greatest positive value, so half I peak. And the resistance is 160 ohm. So therefore the voltage is, and then I peak is 0.3 ampere from the question C. So the answer is 24 volt. So the voltage across the resistor is 24 volt. Okay, for capacitor, question E2, from V equals to V naught sine omega t minus 90 degrees, and V naught is equals to I naught C, or another word, V naught is V peak. V peak equals to I peak XC, reactance of the capacitor. And then reactance of the capacitor is equals to 1 per omega C. Okay, we substitute I peak into the equation 0.3, and then the angular frequency 1826 radian per second, and then the capacitance 25.0 microfarad, convert to farad. Okay, next is omega t. So for omega t, we use I equals to I naught sine omega t. For capacitor, I leads V by pi per 2 radian. So if V equals to V naught sine omega t minus 90 degrees, therefore I is equals to I naught sine omega t. So pi per 2 radian convert to degrees is 90 degrees. So we can use radian here or degrees here. So now substitute I into the equation. 1/2 its greatest positive value means half I naught. So cancel out the I naught. So therefore sine omega t is equals to half. And omega t is equals to 30 degrees and 150 degrees. So there are 4 quadrants. For positive value, the 2 quadrant 30 degrees and 150 degrees will give you positive value of sine. Okay, now we substitute omega t into the equation here. So if we substitute 30 degrees, we get the voltage negative 5.69 volt. And if we substitute 150 degrees into the equation here, we get voltage equals to 5.69 volt. So this is the answer, voltage across the capacitor. Okay, that's all for the question. Hope you all can understand. Thank you for watching. The end.